In this example, we're going to try to connect these graphs of these exponential functions to the transformations that we've talked about in previous units. For this particular problem, we're going to consider the graph of y equals 3 to the x. We're going to consider that our parent function, that exponential function, y equals 3 to the x. And we want to know what transformations have been applied to the graph of y equals 3 to the x to obtain the graph of y equals negative 1/3 to the x. So what does placing a negative out in front do to the graph? That's right, it would reflect it over the x-axis. And then the 1/3 right there out in front, that would be a vertical compression by a factor of 1/3. So assuming that you know what the original graph should look like from before, y equals 3 to the x, I'll make a real rough sketch of that right here. It should have an initial value of 1, since there's no a value out in front of this. That would be my y-intercept, and then a growth factor of 3. So it will pass through 1, and it will look something like that, just making a real rough sketch of it. So this graph, I want to make a real rough sketch of that. It will reflect over the x-axis, and it will not go down quite as fast. Like that, it will look a little something. It'll still, it'll pass through right here at 1/3 this time, and then it will go down not quite as fast as the other one. That doesn't quite have that same steepness of a curve as the other one does there. So again, all the y values would be 1/3 of what they were, and then reflected over the x-axis. Doesn't really matter which order you apply those transformations. So now that we know that, let's talk a little bit about the domain, the range, the equation of the horizontal asymptote, and all those, and the y-intercept and all that stuff as well for that. So again, I just draw that rough sketch over here. This was 1/3, we said, and this graph was doing something like this for that. So if we wanted to talk about the domain of that, again, the domain being the x values or all the input values, this goes forever to the left and forever to the right. So the domain here would be negative infinity to positive infinity. The range, again, remember the range is the y values, and you always want to build these interval notations from least to greatest, so working from the bottom up, the range would be from negative infinity until 0. Doesn't ever quite make it to 0. The y-intercept, and we said the original one, y equals 3 to the x was 1, and we compressed that to 1/3 and reflected it, so the y-intercept would be negative 1/3 for this. And then finally, the horizontal asymptote. That line that this graph is approaching as it goes towards negative infinity, that would be the x-axis, which would be the equation of the horizontal line y equals 0 for that. So again, this is the equation of a horizontal line, so it should take the form y equals a number. Our y-intercept, we found right there. Again, there's several ways we could do that. We could also just plug 0 in for x. 3 to the 0 power would be 1. 1 times negative 1/3 would be negative 1/3 for that. And then again, we've already talked about the domain and range. So more or less in this section, we're going to be analyzing the characteristics of these graphs, since it's not really very easy to create a whole bunch of accurate graphs of this. We lose a level of accuracy pretty quickly just because of how large or small the numbers tend to get for these. In this example, we're going to consider the function y equals 2 to the x. We want to know what transformations have been applied to the graph of y equals 2 to the x to obtain the graph of y equals 2 to the quantity x minus 4. So really the only thing that's different here is this minus 4 in the exponent. That is what I'm calling the interior of this function. And as we can recall from previous transformations, when we studied other functions, subtracting 4 on that inside or the interior of the function actually moves it right 4 units. So this would be a translation 4 units to the right for this. So if I wanted to do a rough sketch of what y equals 2 to the x looks like, it has a y-intercept of 1, something like that. This is that horizontal asymptote line of y equals 0, or the x-axis right there, again passing through 1, and so on. So now I need to translate this 4 units to the right. So just a quick rough sketch of that. I want to move this over 4 units to the right. This point 0, 1 right now would be over here at 1, 2, 3, 4, 1. So that point is over here now. And then the graph is going up and doing this, and it's coming down. And the y-intercept should be much lower than it was before. So now we need to go ahead and analyze those same characteristics that we talked about before. So the domain for this, again, looking at the graph, we can see it continues forever to the left and right still. So its domain would still be all real numbers, or negative infinity to positive infinity in the interval notation. The range for this particular function, the range, again, we're talking y values. We're building it from least to greatest, so it's from here up. So that would be from 0 to infinity. Infinity always gets the parenthesis. 0, we're not actually getting to 0. We're just approaching 0 there. So it'll be a parenthesis as well. The y-intercept. Again, we could just plug 0 in for x for this. If we plug 0 in for the x, 0 minus 4 is negative 4. We have 2 to the negative 4th power. Remember, 2 to the negative 4th power would become 1 over 2 to the 4th power, using an exponent rule from Algebra 1. And 1 over 2 to the 4th power would be 1/16. For that. And then finally, I had the question about the horizontal asymptote. And again, this is still the line y equals 0. Still the x-axis right there. Still that horizontal line. So we still have y equals 0 for this particular example. Okay, in this particular example, we're going to consider the exponential function y equals 1/2 to the x, which is an exponential decay function. We want to know what transformations have been applied to the graph of y equals 1/2 to the x to obtain the graph of y equals 20 times 1/2 to the x power plus 10. So looking at this, you can see the parent function 1/2 to the x still in there. We've got this 20 out in front of it, and we've got this plus 10 at the end. So if we talk transformations, this 20 out in front would be a vertical stretch by a factor of 20. In this case, that's changing the initial value from 1 to 20, which you can see you took the original initial value of 1 from this function and multiplied it by 20 to show that stretch. 1 times 20 is 20, which would give that new initial value, or new y-intercept. And then finally, this plus 10 at the end, remember from the previous unit that adding 10 at the end is just a vertical translation, so then it's just going to shift the whole thing up 10 units with that. So if we want to do a rough sketch of that, y equals 1/2 to the x for a second. It would pass through 1 here on the axis, and it would come down roughly like this. This is a rough sketch of the parent function, y equals 1/2 to the x right there, just to give you an idea of what we're looking at. And then we need to stretch everything vertically by a factor of 20, and then we need to move that up 10. So that's going to make things go much steeper. I'll go ahead and show that kind of in 2 steps. If I just stretched everything up by a factor of 20, we'll go ahead and move the y-intercept up here to 20 now, and this graph is coming down and doing something like this. And then finally, I need to move that up 10, so that would look a little something like this. Now where I was at the 20 right there, that point's been moved up 10, so now it's up here at the 30 where it's crossing the axis. Somewhere down here is 10. That's going to be where my asymptote line is that it never gets to. It just kind of approaches, and the graph should be coming down and doing something like that. Again, that's a really rough sketch of that. It shows that stretch by a factor of 20 here, and then I just took that whole thing and moved it up 10 units for that. So I'm going to just go ahead and leave that sketch on the board for a second, erase these other ones here, so now I can answer the questions that we've been answering in the other problems about the domain, the range, the y-intercept, and any horizontal asymptotes. So if we wanted to talk about the domain of that, again, it goes to the left and the right forever. So our domain is still all real numbers, or negative infinity to positive infinity. Our range on the other hand, will change. If you look at this, our range, our y values, they don't go all the way down to 0. They don't go all the way down to negatives. The horizontal asymptote line here at 10 is showing that this graph is only contained from here up. So the range for this would be from 10 to infinity. We're going to get an output value of 10 or less for this. The y-intercept, we said, initially was 1. Then when we stretched it by a factor of 20, it became 20. And then finally, when we shifted the entire thing up 10 units, it became 30. You should be able to see that just by plugging 0 in for x right here. 1/2 to the 0 power would be 1. Anything to the 0 power is 1. Times 20 would be 20, plus 10 would be 30. So that's been confirmed by plugging in 0 as well. And then finally, the horizontal asymptote. That equation of that horizontal line that this graph is approaching as it goes to the right would be the horizontal line y equals 10. So again, so that is the equation of a line, so make sure you're including the y equals part on that if I ask you to write the equation of the horizontal asymptote line.